So we left off working on the nitrogen nucleophile mechanism, and we had formed one CN bond, we had broken a CO bond, and we had done a proton transfer, forming an OH bond and breaking an NH bond. So here we are with our neutral molecule. And again, if we are in acidic solution, which we are, pH 4 to 5, then ideally all of our intermediates are going to be either neutral or have a positive charge on, and we will not be forming anything with any net negative charge on it. We're not going to be generating a strong base in an acidic solution. So one of the things that we want to do to get to the end product is to remove this hydrogen right here. But if that hydrogen is removed, then we have a nitrogen with a negative charge, which is a really strong base. So that's not something we want to do next. One thing that we want to do is get rid of this oxygen and have it turn into water. So one of the things that we need to do along the way is to form a new OH bond. And so in acidic solution, we can do another proton transfer. And if we do that proton transfer, then we end up having this thing with a net positive charge on it. We have protonated our leaving group, and we have a good leaving group there. And we can add that to our list here. We are doing another proton transfer. Then we're ready to do an elimination. We can, and if we did this proton transfer, so we're forming an OH bond and we're breaking an OH bond. The net result here, we got to be a little bit careful of how we're using this. We're H3O is a catalyst, and so we're going to add the proton, but then the catalyst is going to be regenerated at a later point. So here all we're doing is we're actually, let's be careful here about how we're using our terminology. So if we're doing an acid-base reaction that is an internal acid-base reaction, then we will call it a proton transfer, because it's transferring it from one part of the molecule to another. If we're just adding a proton onto the reactive intermediate, then we're going to call that a protonation. So sorry about that, let's change this to protonation. Protonation, okay. And so then the next step we were thinking about, we got to form a double bond here, and we have to get rid of this, we have to get rid of water here and break that other carbon-oxygen bond. So in the next step we can do that, which we are forming a pi bond here, leaving a positive charge on nitrogen. And so again, we have neutral, intermediate, something with a net positive charge. We do something and it still has a net positive charge. And we always are looking for an intermediate with it's either neutral or a net positive charge, not a +2 charge, not a -1 charge. Okay, so here we are after our forming of our pi bonds, we've done an elimination. And this looks almost like our final product. The only thing that we have left to do here is to deprotonate it. And so we can just show the proton coming off into solution, or we can show our water pulling it off, reforming H3O. And so up here we added H3O as our acidic solution, and here we reformed H3O. And so the H3O is acting as a catalyst. So the last thing we're doing to our product here is removing that proton, giving us our neutral product. And so this is deprotonation. So step number 1 was addition, step number 2 was proton transfer, step number 3 is protonation, step number 4 was elimination, and step number 5 is deprotonation. And you'll see this again, but this is kind of a normal sequence of events in acidic solution. You see this a lot. You protonate, you do something, and you deprotonate. So you could do protonation, substitution, deprotonation, protonation, elimination, deprotonation, protonation, addition, deprotonation. But this acid catalyzed sequence of events where you protonate, you do something, and you deprotonate is kind of a standard order which you see things carried out. So as we worked through this, for the most part, our goal was to do something, and we haven't checked off. Let's check off. We made everything. We formed the second CN bond here in the elimination step. We broke the CO bond when we lost water up here, and then we broke one NH bond earlier, and now we're breaking the second NH bond, and the OH bond is the second OH bond that we formed, is the one forming water. So this original oxygen up here became water. So we added one proton on there, we added another proton on, and then we kicked it out as water. But with the exception of this first step, this whole thing is carried out in acidic solution, and our goal for each step would be that that the intermediate that we create in that step would be a reasonable intermediate, and that reasonable intermediate would mean that it would have either be neutral or have a net positive charge on it, but it wouldn't have a net negative charge on it in acidic solution. And we wouldn't be creating basic atoms in an acidic solution there. Okay, so the third mechanism that we're going to work through is going to be the oxygen nucleophile on the back of this blue sheet. And before we start the next video, then you can list from the pink sheet all the bonds that are going to be broken and all the bonds that are formed in this reaction, and we will work through this. Again, this is under acidic conditions, and so everything that we're going to work through in this mechanism will have either be neutral or net positive charge, and there will be nothing that will have a negative charge in it. So go ahead and list on the bottom of this sheet all your bonds broken and bonds formed, and then we can check them off as we go through this mechanism.